questions 11 through 20 on the 2007 grade 10 AMC 10B. A circle passes through the three vertices of an isosceles triangle that has two sides of length 3 and a base of length 2. What is the area of this circle? The diagram will look approximately like this, and the very first thing I would like to do is draw a perpendicular from the very top to the base of that triangle, like that. And I'm going to draw the center of the circle, so most likely about here, that red dot. And then I'll just connect the other vertice to the center to represent that radius. And now let's label this diagram. This is the radius from here to here. Similarly, this is the radius. And this distance I don't know, so I will call that x. This distance is 3, this is 3, and this is 2. Now, since in an isosceles triangle, the perpendicular will cut that in half, this is 1, and this is 1. So there we go. We're going to have probably some Pythagorean relationships since that perpendicular creates a 90-degree angle. So the first one is this triangle right here. That gives you 1 squared plus x squared is equal to r squared. And the second relationship is this big one right here, this triangle. And from that one you get 1 squared plus x plus r squared is equal to 3 squared. And we got two equations, two variables, so hopefully we'll be able to solve for this. So this one gives me x plus r all squared is equal to 9 minus 1, which is 8. So x plus r is going to be root 8, like that. And we can isolate for x root 8 minus r. Then substitute this back into here, and that will give me x squared, which is root 8 minus r all squared, is equal to r squared minus 1, like that. So expanding, we get 8 minus 2 root 8 r plus r squared is equal to r squared minus 1. The r squareds cancel, and this just becomes 9 is equal to 2 root 8 r. And this looks like r is 9 over 2 root 8. Rationalize the denominator, multiply top and bottom by root 8, and this will give you 9 root 8 over 8 times 2, which is 16. And I think that root 8, you can break that into 2 root 2. So that becomes 9 times 2 root 2 over 16. And finally, in lowest terms, it would be 9 root 2 over 8. And they want you to figure out the area of the triangle, or area of the circle rather. So area of the circle, of course, is pi r squared. So pi times r squared. R is 9 root 2 over 8 all squared. So that's pi times, let's see here, 81 times 2 all over 64. And in lowest terms, that looks like pi times 81 over 32. And that is choice C for number 11. Tom's age is t years, which is also the sum of the ages of his 3 children. His age n years ago was twice the sum of the ages of their ages. Then what is t over n? So Tom's age is equal to his 3 kids, K1, K2, and K3. And Tom's age n years ago, so t minus n, was 2 times the sum of the ages of the kids back then. So it'd be K1 minus n plus K2 minus n plus K3 minus n. All right, so these are the two equations that we have to use to get t over n. Well, you simplify a little bit here. To we can group the k's together, k1 plus k2 plus k3, and then this looks like minus 3n like that. Well, k1 plus k2 plus k3 is just t, so that becomes t minus n is equal to 2t minus 3n, like that. And therefore this is t minus n is equal to 2t minus 6n. Solving, we get t on this side, add 6n to both sides, and it gives you 5n. And then finally, we get our ratio t over n is equal to 5. So number 12, the answer is D. Two circles of radius 2 are centered at 2, 0, and 0, 2. What is the area of the intersection of the interiors of the two circles? This is the diagram of the question, and let's label this now. They told me that the centers are 2, 0 and 0, 2. And they are interested in us figuring out the area of that common region. So how can we do that? The best thing to do is draw a line that cuts it in half like this. And then I'll draw a line that creates a triangle like that. Now, I will call half of that interior A, like this. And therefore, if I can figure out A, I'll just multiply it by 2 at the end, and that will be my answer. Now, how do I get A? Well, this is a right triangle, the way I've drawn it, and you get A as follows. A will be equal to the area of a quarter circle minus that triangle. And if you see that, I hope you will believe me, that will give you A. There's the quarter circle, and if you subtract from that this triangle, it will leave you with that segment I have labeled A. So let's figure this out. A quarter circle, of course, is pi r squared divided by 4, and that triangle is 1/2 base times height. So the radius of the circle is 2, so pi 2 squared over 4 minus 1/2 base looks like 2, and the height is also 2 for that triangle. So that leaves me with 4 pi over 4, which is just pi, and then 4 over 2, which is 2. So that is A. Now, what I'm interested in is this full area, this whole common area. And that common area basically is 2A. So 2A would be equal to 2 times pi minus 2. And that is, for number 13, choice D. Some boys and girls are having a car wash to raise money for a class trip to China. Initially, 40% of the group are girls. Shortly after, 2 girls leave and 2 boys arrive. Then 30% of the group are girls. How many girls were initially in the group? We'll represent B and G as the number of boys and girls. So initially, the number of girls over the total was 40%, so 0.4. And then later, we had 2 girls leave, so G minus 2, but 2 boys arrive. And using these numbers, if you calculate the percentage of the total, which would be B plus 2 plus G plus minus 2, that is 0.3. So there you go. You got 2 equations, 2 variables, and we have to solve. We have to basically find the value for G. So from the first one, we get G is equal to 0.4B plus 0.4G, like that. So therefore, this is 0.6G is equal to 0.4B. And I'll just isolate in terms of getting something like G, because that's what I have to substitute into here. So that means B is equal to 0.6 G divided by 0.4. So that's what I'll substitute into here. So here we go. Let's simplify this a little bit first. We'll get G minus 2 is equal to 0.3B plus 0.3G and the 2's cancel actually. So all I'm left with is just g minus 2, and where I can bring the g's over, so that will give me 0.7 g minus 2 is equal to 0.3 b, and b is 0.6 g over 0.4. All right, so this looks like it will be 0.3 times 0.6, so that is 0.45 g, 0.7 g minus 2. Bring the 2 over, and that looks like 0.25 g. So therefore g is equal to 2 divided by 0.25, and that is 8. So initially the number of girls was 8. So therefore number 14, the answer is C. The angles of a quadrilateral ABCD satisfy angle A is equal to 2B is equal to 3C is equal to 4D. What is the degree measure of angle A rounded to the nearest whole number? So we have A is equal to 2B is equal to 3C is equal to 4D. So let's get everything in terms of one variable. Well, we have D by itself, that's fine. 3C is equal to 4D. So that means C is equal to 4D over 3. So that's my C. 2B is equal to 4D. So that means B is equal to 2D. So that takes care of B. And then finally A is equal to 4D. So there we go. We got all the angles in terms of D. Now, in any quadrilateral, the sum of the angles is 360. So that means A plus B plus C plus D is equal to 360. So sub in our values, we got 4D plus 2D plus 4D over 3 plus D is equal to 360. Like that. Adding this, we get, let's see here, 7D plus 4D over 3 is equal to 360. And that looks like, let's see, top and bottom by 3, 21 plus 4, 25D over 3 is equal to 360. And therefore, 25D over 3 is equal to 360. So D is equal to 3 times 360 divided by 25. And that is approximately 43.2. They want you to figure out angle A. Okay, well, A is equal to 4D. So A is equal to 4D, which is going to be about 172.8. 172.8 rounded to the nearest whole number is 173. So number 15, the answer is D. A teacher gave a test to a class in which 10% of the students are juniors and 90% are seniors. The average score on the test was 84. The juniors all received the same score. The average score of the seniors was 83. What score did each of the juniors receive on the test? So let's just make our lives easy here. Let's say there's 100 students. And therefore, we've got 10% as juniors, so that means 10 students are juniors, and 90 students are seniors. And the score that each junior gets is unknown, so I'll just label it X for now. And the scores that the seniors get, the average is 83. So I can just write 83 there. We can treat it that every student got 83. Even though that's not true, we can use that number. So the total average is going to be 10x plus 90 students times 83, all divided by 100. And they tell you that total average is 84. And this will allow us to solve for x. So 10x is equal to plus 90 times 83, so 7470 is equal to 8,400. And therefore 10x is equal to 930. Therefore x is equal to 93. So number 16, the answer is C. Point P is inside equilateral triangle ABC. Points Q, R, and S are the feet of the perpendiculars from P to AB, BC, and CA respectively. Given that PQ is 1, PR is 2, and PS is 3, what is AB? So let's draw a triangle first. It's equilateral. So here we go. And we are going to choose some P somewhere in here. So I don't know where the P is, but I'll just call it here. And we have to draw perpendiculars to each of the sides. So this perpendicular from this one, and then this perpendicular, and that perpendicular like that. All right, and let's label this. This, of course, was P, and we have A here, B here. When it drops to AB, that is represented by Q, and then this is C, obviously. When it drops to CB, that's represented by R, and the perpendicular to AC, or CA, is S. And they give you those distances. PQ is 1, PR is 2, and that's 3. Sorry, not drawn to scale, but that's okay. Now, AB is the length of the side, right? And I don't know that, so I'm just going to call it X. And since this is an equilateral triangle, CB is X, and so is AC. All right. So how do we do this question? All right, let's think about this for a second. A few things are running through my mind. Maybe Pythagoras, but for some reason I don't think that's going to help very much. I think areas. If you divide this into triangles and then use the area, I think that will be able to do this pretty quickly. So let's first look at the 3 triangles. This one is the first one. What is the area? It is 1/2 base times height. The base is from there to there, which I have called X, and the height is 2, because that's a perpendicular. So there you go. Now let's add to that the next triangle, which is this one right here. In a very similar way, it's 1/2 base, which is X, and the height this time is 1. And then finally, add that triangle. 1/2 base times height, base is X, and the height this time is 3. All right, so that represents the total area when you add them all up. But I can get the total area also in a very similar way with the same diagram, but using X and only X. How? Well, drop a perpendicular from top to bottom like this, from C all the way to the bottom, like that. And that will help us figure out the area in terms of X and only X. And then therefore we can just solve this equation. Now, to avoid making this diagram messy, I'm going to just duplicate this one more time, this triangle. And when you do that, this is of course a right angle. This was X, and so therefore this is X over 2. Now I want to get this distance in terms of X. Is that possible? Because that represents the height of that triangle. And the answer is sure, because this was 60 degrees. How do I know that? Because equilateral, triangle. And therefore this is 30 degrees. So the ratio of the sides of an equilateral triangle, by now I hope you know that it is 1, 2, and root 3, the ratio of those sides. So we can get H in terms of X. H over X over 2. Look at the ratios, root 3 over 1. All right. So that means H is equal to root 3 X over 2. So going back here, remember this whole thing that we got is equal to A, but what is A? A represents the total area of the triangle, which is 1/2 base times height. The base is from here to here, which is X, and the height is H, but H I just got in terms of X, root 3 X over 2. And it equals this whole thing. So let's simplify that. That looks like x plus x over 2 plus 3x over 2. All right? There we go. This is going to give us our value for x. So the left side looks like root 3x squared over 4. And then the right side looks like 3x over 2 is 1.5 plus half plus 1, 3x. Okay? Divide both sides by x, and you'll get root 3x over 4 is equal to 3. And therefore, x is equal to 3 times 4 all over root 3. And if you rationalize the denominator, which is they most likely want you to do, this is going to be 12 root 3 over 3, which is just 4 root 3. And remember, x represented my length for AB. So that means AB is equal to 4 root 3. So AB is 4 root 3, and number 17, the answer is D. A circle of radius 1 is surrounded by 4 circles of radius r as shown. What is r? Here is that diagram blown up, and let's draw some lines and get some understanding of this. The very first thing I want to do is draw a square that connects all 4 centers of these large circles. There we go. And then I will draw a line from the vertices that represents the diagonal of the square. And I think that should be it for this. Now let's label this. From here to here, of course, is just the radius. And this is, of course, the radius, so that's another r. Very similarly, that's r. And this is r. Well, they're using small r. It doesn't matter. I'm using big R. It's the same value. I'll write it up here. R is equal to R. All right. Well, this is R also from there to there. But this R is the small circle. So from here to here is actually 1. And then therefore this whole distance is actually 2 because that represents the diameter. So this guy, that's 2. And then this is, of course, r. So we've got a Pythagorean relationship. Since it's a square, that's a right angle. And it is as follows. 2r all squared plus 2r all squared is equal to 2r plus 2 all squared. And this will allow me to solve for r. So this is 4r squared plus 4r squared is equal to 4r squared plus, let's see here, 8r. Or actually, I don't think I need to expand it. It'll be probably quicker if I don't. Well, it doesn't really matter. It probably won't be that much longer if I expand it, but let's just not expand it. This gives me 8r squared is equal to 2r plus 2 squared. Now if I take the square root of both sides, I get root 8r is equal to 2r plus 2. And then put the r's on one side, and you get root 8r minus 2r is equal to 2. Factor out the r, and you'll get root 8 minus 2. And therefore, r is equal to 2 over root 8 minus 2. And that is, of course, the right answer, but we have to rationalize the denominator. So root 8 plus 2, root 8 plus 2. This gives me 2 root 8 plus 4. And the bottom will give me 8 minus 4, which is 4. And therefore, this looks like, well, root 8 is 2 root 2. So that's 4 root 2 plus 4 all over 4. And finally, that's root 2 plus 1. So, and that is, of course, equal to r. Root 2 plus 1 is the radius of this circle. And that is, for number 18, choice B. The wheel shown is spun twice, and the randomly determined numbers opposite the pointer are recorded. The first number is divided by 4, and the second number is divided by 5. The first remainder designates a column, and the second remainder designates a row on the checkered board shown. What is the probability that the pair of numbers designates a shaded square? Okay. Well, first and foremost, let's just work through this with no special tricks, just, case by case. So these are my numbers, right? I've got 3, 6, 1, 7, 9, 2. When it's spun the first time, it lands somewhere, and I've got to divide it by 4. And I've got to write the remainder here. All right. Well, what are the remainders when you divide by 4? Well, this remainder is 3. This is 2. This is 1, 3, 1, and 2. Now, I do the same thing. I spin it once more, and it can again land at any one of those. But this time I divide by 5 to get a remainder. And when I do that, I get the following numbers. I will get 3, 1, 1, 2, 4, and 2. All right? So I'm working with these guys. Now, I've got to make pairs. The first one and the second one. So for example, 3, 2 is one possible pair. And those pairs represent the column and the row. So column and row. Column and row, like that. So there's going to be, for the first number, 6 possible choices, and for the second number, 6 possible choices. So there will be 36 in total. So let's write them out. It shouldn't take that long. Let's see here. For the first number, it's going to be a 3. That represents my column. And then the second number can be any one of those guys. So 3, 1, 1, 2, 4, 2. So you see how I got that? All right. I'll just do one more and then I'll just fill in the rest. Second number, it can be 2. And then the row number is represented by any one of those. So 3, 1, 1, 2, 4, 2. All right. So those are basically going to represent our numbers, and I'll just fill in all of these and then I'll come back. So that completes the table. Now I've got to turn my attention to the shaded squares. What are the coordinates for the shaded square? So this first one, for example, for the column is 1, and for the row is 1. Remember, these are the columns, these are the rows. The next shaded one is there. That's 3 for the column and 1 for the row. They've kind of done it in a weird way. The columns is fine, but for the rows, they've gone up instead of going down, which is a little confusing, but that's okay. The next shaded square is the second column, second row. That shaded square is the first column and the third row. The next shaded square is the third column and the third row. And the final shaded square is the second column and the fourth row. So any of these numbers, if they're one of these numbers, they will be a shaded square. So 1, 1, let's look at the first one. Anywhere there's a 1, 1, I'll circle it. These are 1, 1s. Okay? 3, 1, these are 3 1s. 2, 2, these ones, let's see here, where's the 2, 2? Any more 2, 2s? Oh, down here. 1, 3, 1, 3, here's a 1, 3, here's a 1, 3. 3, 3, there's a 3, 3, there's another one. And then finally 2, 4, here's a 2, 4, and here's a 2, 4. I think that's it. So how many did I circle? 1, 2, 3, 4, 5, 6, 7, 8, 9, 18. So I circled 18. And how many was the total? It was 36. So that is my probability. In lowest terms, that is a half. So number 19, the answer is C. A set of 25 square blocks is arranged into a 5 by 5 square. How many different combinations of 3 blocks can be selected from that set so that no two are in the same row or the same column? So let's make a little diagram here. Let's partition this into 5 by 5. And let's label each of these squares 1 through 25 like this. Okay, so now let's discuss this question. Let's talk about it. We want to choose 3 blocks. So block number 1, block number 2, block number 3. But the rule is that no two can be in the same row or in the same column. So let's just start with this block right here. Block number 1. Like that. And if I do that, that's great. But now I'm not allowed to choose any of these. Why? Because they're in the same row. I'm also not allowed to choose any of those. Why? Because they're in the same column. So I'm only allowed to choose from these guys. And how many of them are in that square that I just drew? Well, there's 16. So I've got 16 possible choices. Okay, don't get confused. This is not the number 16. It's not that guy. It's just the number of choices. But I still got one more. Okay. I'm limited to these 16, right? So let's just choose one at random. I don't know, just choose 19, the number 19. If I chose that for my second block, then I'm not allowed to choose any of these. Why? Because it's in the same column, and I'm not allowed to choose those numbers because they're in the same row. I can only choose this guy, those guys, this guy, that, and that. And that is 1, 2, 3, 4, 5, 6, 7, 8, 9. Does that make sense? I'll just do it again. I can't choose the ones that I've circled in red. I can only choose the ones that I'm circling in orange because they are not in the same row or column. Correct? And those are 9 in terms of how many. So that puts 9 here, and this is how many possible combinations. 16 times 9. And that is equal to 144. Now we can do the exact same system for any other number. We could do the exact same thing for 2, for 3, for 4, all the way up to 25. So for each number from 1 to 25, there's 144 possible combinations. So 25 times 144 is our total, and that is 3,600. And 3,600 is one of the answers. But don't circle 3,600. Why? Because we have overcounted. And overcounting is common on math contests. Why did we overcount? And how did we overcount? Well, I'll give you one example. We'll just use the example that we used earlier, that we had chosen 1 as my first number, 19 as the second number, and actually I don't think we chose the third number, so I'll just choose 1, 12, let's say. Okay? If I chose those, 1, 19, and 12, I can choose exactly the same 3 numbers in a different order. 1, 12, 19. Or how about 12, 1, and 19? Or 12, 19, and 1? And, of course, 19, 1, and 12, and 19, 12, and 1. Notice all of these are basically the same 3 blocks, same 3 numbers. And there's 6 possible ways of rearranging them or choosing them. See what I mean? So this 3,600 counts every combination 6 times. So to get the number of unique combinations, how many different combinations, you have to take this 3,600 and divide it by 6. And if you do that, you get the answer 600. And number 20, the answer is C.